In our first module, we are going to be working on finding area. The first type of area that we're going to solve for is an area within a circle, and it's called a sector. A sector is just a section of the circle. It is formed by a central angle, and you can see that it kind of looks like a pizza slice. We will need the degree measure of the central angle, and we will need the radius to be able to solve for the sector. The formula is x, which stands for the degree measure of the arc, times pi r squared, which you may recognize as the area of the circle. I would recommend you simplify the numerator first, and then you're going to divide that by 360, the total number of degrees in the circle. So in this first problem, we see that we've got a shaded region, and the central angle is 51 degrees for that region. And BC, we can see, happens to be the radius. So that means our x is 51, our r is 16. And we're going to plug those numbers into the formula. 51 times pi times 16 squared. We're going to simplify that. And then once we've simplified that, we're going to divide by 360, and we will get 113.94 feet squared. Keep in mind that area is always a squared unit. The next problem gives us the central angle for the unshaded sector, and we're being asked to find the area of the shaded sector, so we've got to find that other angle. They do tell us that GH is 13 yards, and we can see that GH is the radius. So in order to find the central angle for the shaded region, we're going to subtract the 126 from the total number of degrees in the circle, which would be 360, and that will give us 234 degrees, which would be the central angle for the part of the circle that we want to solve for. The radius is 13. We're going to plug those two numbers into the formula, 234 times pi times 13 squared. Simplify that, divide by 360, and we'll come up with 345.1 yards squared. And then finally, sometimes the shaded region is not all in one place. So we can see in this diagram we have two shaded sectors. The one sector on the bottom part of the circle gives us the central angle of 46. Fortunately, we can see we've got vertical angles, so both of the sectors would have a central angle of 46, and HG, which is the radius, is 7 centimeters. So for the x variable, the arc degrees, we're going to add the two central angles that we know, 46 plus 46, and we're going to get a total of 92, and that will be the number that we use as our x, and our radius is 7. We will plug those numbers into our formula. We get 92 times pi times 7 squared. We'll simplify that, divide by 360, and we get 39.34 centimeters squared. The other type of area that we're going to solve for is the area of a composite figure. A composite figure is a figure that can be separated into two basic plane figures. In the diagrams that we're going to look at, we won't have a specific area formula for every single composite figure, but we can divide it into things that we do have formulas for, and once we've found the parts of that figure, then we can add them together. So in this particular figure, you can see that there is a rectangle on the top portion, and it is sitting on top of a trapezoid. So we're going to use the area for the rectangle, Then we'll separately find the area for the trapezoid, and we'll add those two together, and that will give us the total area. So for the rectangle, we're going to use the area is length times width. For the trapezoid, 1/2 height times base 1 plus base 2. For the rectangle, we can see that length and width are 23 and 12. So we're going to plug those into the formula and get for the rectangle 276 centimeters squared. For the trapezoid, we need the height and the two bases. So the segment on the bottom, the base is 15 centimeters, and we know the one on the top would be 23 because it's part of that rectangle. We need the height. The height is going to be perpendicular to the base, so in this case the height is going to be outside of the trapezoid. The rectangle is 12 centimeters. Out of that 18 centimeter height, 12 of it is the rectangle, so that would leave 6 for the trapezoid, and that 6 is going to serve as the height. So we're going to plug those numbers in, 1/2, 6 times 23 plus 15 to get a total of 114. We've got 276 for the rectangle, 114 for the trapezoid. We add those two numbers together and we get a total of 390 centimeters squared. For this particular diagram, in the very center of this figure is a parallelogram, and on each side of the parallelogram we see a semicircle. We're going to use those two shapes to find this area. Once we find the parallelogram area and the circle, we're going to add it together to come up with the total. So for the parallelogram, we need the base and the height for the formula. The base we would find by looking at that diameter for the circle. If one side or the radius is 6 inches, then to find the diameter we would double that. So the diameter would be 12. That means the base of that parallelogram would also be 12. The height of the parallelogram is going to be the 5. Notice that that segment is perpendicular to the base, and that kind of clues us in that that would be the height. So 12 times 5 would give us 60 inches squared for the parallelogram. And then for the circle, we've been given the 6 inches, which is the radius. So we're going to plug it into the circle formula for area, and we've got pi times 6 squared, which would give us 113.1 inches squared. We're going to add those two areas together, the 60 and the 113.1, to get a total of 173.1 inches squared.